Good morning. So today our lesson is going to be on using recursive rules with sequences and functions. So up till this point, we've been kind of focusing on explicit rules, and those are rules that act more as an input-output table would with a function. So you have an n value, which is your input value, and that is the number that you are on the sequence. So let's say you want to know the fifth term in the sequence, your n value would be 5. You would input the 5 and your output would be what is that fifth term in the sequence. Or if you want to know the seventh term in your sequence, you would input the 7 as your n value and your output or your a sub n would be the seventh term in the sequence or anything in that matter. So it's sort of like you input which one you want and then the output is the number in the sequence that you want. Today we're going to work on recursive rules. Recursive rules are a little bit different. So a recursive rule for a sequence that gives the beginning term or terms of the sequence and then a recursive equation will tell you how the nth term is related to one or more preceding terms. So what that means is we can't simply just input like a 5 or a 7 or whatever number we want to find in the sequence, because the pattern of the sequence or the rule that's given to you is based off of what's happening to the preceding numbers. So instead of saying like, oh, to get my third term, I'm just going to plug in a 3 and get what it is, you have to do something mathematical to the previous term or maybe the previous 2 terms. So maybe you're like, oh, I have to take the number before it, multiplied by 5, and then that will give me my next term. So it's just a different way of looking at it. So it's looking at it more as like a pattern, what's happening with the preceding numbers versus an input-output type of function. So first thing we're going to do is write the first 6 terms of the sequence by using one of these recursive rules so we can kind of see how they work. So first thing I'm going to do here is go over how to find those first 6 terms. So now when I want the first 6 terms of my sequence, basically what I want to do is I want to find my a sub 1, my a sub 2, my a sub 3, my a sub 4, my a sub 5, and my a sub 6. That's really what I'm finding. So a sub 1 is always like, what's the first term in your sequence? A sub 2 would be your second term, and so forth. So we want to know the first 6 terms. Now, they have to start us off with something when we use a recursive rule, because you can't figure out the next number in the pattern if you don't have something to start with. So they have to at least give you the first term. Sometimes they'll even give you 2 numbers if maybe you have to do something with the 2 preceding numbers together. So in this case, they're just giving us the first term, which is -2. Now, if I want to find, let's say, the second term in the sequence, so my n is going to be 2, that would mean n minus 1 is really 2 minus 1, so that would be a sub 1. So what that means is, to get the second term in the sequence, I have to take the first term in the sequence and add 3 to it. Now, obviously, I wouldn't be able to do this if I didn't already know what that first term was, but they gave it to us, and we know that it was -2. So -2 plus 3 is +1, so I know that's the next number in my sequence. So now I would repeat this process. So now to find the third number or term in the sequence, I'm going to take, if my n is now 3, because it's the third term, my a sub n minus 1, that's telling me, well, what's the 1 before it? So a sub 3 would become 3 minus 1 here. The 1 before it is a sub 2. So I'm going to have to take, well, what was my second term in the sequence, right? Plus 3. Well, my second term in the sequence was 1, and 1 plus 3 is 4. So you might start seeing that pattern to emerge now. So to get any number in the sequence using this recursive rule here, you're taking the preceding number. So if I'm finding the 4th term, it would be taking the 3rd term and adding 3 to it. Well, my 3rd term was 4. So if I add 3 to that, I get 7. And then at this point, you probably can just figure out, oh, I see what I'm doing now. I'm going to take the answer I just got from the last one, which was 7. I'm going to add 3, and then I would get 10. And then I'm going to take that answer of 10, and I'm going to add 3, and I'm going to get 13. And that's how a recursive rule works. So let's try number 2. So again, number 2 is giving us an a sub 1 to start with, and then they're giving us this rule here, recursive rule, and they want us to, in order to find the next term in the sequence, we're going to take 1/2 and multiply it to the preceding term. Or you could say they're taking the preceding term and dividing it by 2. So again, we're going to find the first 6 terms in the sequence. So basically, we're going to find a sub 1 all the way up to a sub 6. Now, the a sub 1 was given to us. That's 32. So if I want to find my a sub 2, I have to do half of the preceding term, which is n minus 1. So that would be half of the a sub 1. So my a sub 1 was given to me, which was 32. And half of 32 is 16. So now to find my third term in the sequence, I'm going to do half of my second term, which was 16. Well, what's half of 16? 8. And at this point, you could probably just follow along. Oh, I see. I'm just taking the answer I got or the next number, and you're just cutting it in half, right? So half of 8 is 4. Half of 4 is 2. Half of 2 is 1. So a sub 4 is 4, a sub 5 is 2, a sub 6 is 1. So your first 6 terms of that sequence would be 32, 16, 8, 4, 2, and 1. Okay, so now for number 3. This time they're giving us 2 terms to start with. They're giving us both the a sub 1 and the a sub 2. And this is the rule that we're working with this time here. So we're still going to find the first 6 terms. But they're giving us the first one, the a sub 1 is 2. They're also giving us the second one, the a sub 2 is 5. And then we have to find the next 4 because we need a total of 6. Okay. So to find my a sub 3, since that's the next one that I need to find, notice the formula here, the recursive rule. It says a sub n minus 1. Well, if my n is 3, because I'm finding the 3 term, what number do I get when I do 3 minus 2? I get a sub 1, and that's going to be squared. And then it says minus a sub n minus 1. Well, 3 minus 1 is 2. So basically what's happening is you're taking the term in the sequence that's 2 before it. So if I'm finding a sub 3, 2 before it, and minus 2 would be the a sub 1. And then I'm subtracting the term that's 1 before it. So in this case, that would be 2 squared minus 5. 2 squared is 4. 4 minus 5 is negative 1. So now if I wanted to find a sub 4, I would have to take the term that's 2 before that, which in this case, 2 before that would be a sub 2, and square that. And then I'm going to subtract the term that's n minus 1, so 1 before it, which would be a sub 3. So I'm going to fill in my numbers here. I know a sub 2 is 5, so I'm going to have 5 squared minus my a sub 3, which is negative 1. 5 squared is 25, minus a negative is addition, so that's going to give me a 26. So now you might start seeing that pattern emerge. So you have to take the term, so to find my a sub 5, I have to do 2 before it, which is negative 1, and square it, and subtract the one that's 1 before it, which would be 26 in this case. So negative 1 squared is 1, minus 26 gives me negative 25. And then I'm going to repeat that pattern one more time. So negative 25, 2 numbers before that. Oh, sorry, to find this one, 2 numbers before that would be 26. So 26 squared. And then I would subtract the negative 25, which really means you're going to add it. And that works out to be 701. And that is how you would figure out the terms using that recursive rule. Okay, and then number 4, they're giving us an a sub 0 this time. And then we're going to use this rule right here. Okay, so again, to find the first 6 terms, Now, when they give us the a sub 0, they're technically not giving us any of the terms. They're just giving you a number to start with. Okay, so if they're giving us a sub 0, we still need to find the first 6 terms, and the first term is technically a sub 1. So whatever step you're on, that's the number that the n is going to be. So if I'm finding the first number or the first term, then that means my n is a 1. And then I'm going to multiply that by the a sub n minus 1. So if I'm on a sub 1, if I'm finding a sub 1, then that's going to be 1 less than that a sub 0. If I'm finding a sub 2, then that'll be 2 times the a sub 1, because that's 1 before the 2. If I'm finding my a sub 3, that'll be 3 times a sub 2, and so on, right? So now what is my a sub 0? Well, that was given to us. It's a 1, so 1 times 1 is 1. What about the a sub 1? Well, we just got that. So 2 times 1 is 2. What about the a sub 3? 3 times the answer from a sub 2, which is 2, and that gives me 6. So to find my a sub 4, I'm going to do 4 times the previous answer, and that's going to give me 24. And to find a sub 5, I'm going to do 5 times the previous answer, which was 24, and that's going to give me 120. And then to find a sub 6, I'm going to do 6 times the previous answer. So 6 times 120, and I believe that is 740. And that's how you would find the numbers in your sequence, or the terms in your sequence, using a recursive rule. Okay, so, one thing I forgot to just review really quick before we move on. It did say, tell whether or not the sequence is arithmetic or geometric. So if you were taking a look at your sequence, and you probably would have figured this out as you went through it already, but like this first example here, let's see if I can scroll up. You want to look at the pattern. So you notice you were adding 3 to the pattern each time. So when you're adding 3 each time, then you probably would recognize that that is arithmetic. And that makes sense because your pattern was increasing by 3 each time, right? Add 3, add 3, add 3. Now, when you did number 2, this was divide by 2 or multiply by 1/2. So that would have been an example of geometric. So you could write explicit rules for these as well, like we did last week, but this is just another way. It's a way to write a different type of rule if you just have one number to start with or something like that. Then down here, this one here, 2, 5, -1, it appeared as if, let's see, to get from 2 to 5, you're adding 3, but then you're subtracting, then there is a multiple involved as well, but it's a little bit different. So this one would probably be neither. Some kind of an exponential one, because you have this little exponent in there. And then this last one, again, you are multiplying by a number each time, but you're multiplying by a different number each time. So like times 2, times 3, times 4, times 5. So this would also be neither. Okay, so now going back. Erase that. Okay, so as far as using the recursive rules, that's not too bad. You really just plug in, and you're always taking your answer from the previous term and doing something to it, right? Now, if we review, these are the rules for our explicit. We had our explicit rules that we did. These are now the recursive equations for arithmetic and geometric. So there's both recursive and explicit. So when you are doing your homework, and then when you're doing review and stuff like that, just be really careful. If you see the word recursive, you're looking to do this type of formula. If you see the word explicit, you're doing the ones that we did in 7.2 and 7.3 notes. Okay, so the arithmetic sequence for recursive rule is that your a sub n will equal your previous term, and your previous term is just going to be a sub n minus 1. That always tells you 1 before it. So whatever you're subtracting from that n, in this case n minus 1, that tells you it's 1 term before it. If you're doing n minus 2, that means it's the number that was 2 before the one you're trying to find. And then you're adding D, which is that common difference. And it can be a negative. So if you're adding a negative, that's just like subtracting your common difference, right? Same idea as the D value is still the same idea as what it was with the earlier section that we did on the explicit rules. Then your geometric sequence, this time you have your R value, which is that common ratio, but that's going to be kind of put out front here. And it's going to be multiplied by the preceding term. And that's going to be written as A sub n minus 1. And the n minus 1 is always telling you it's 1 before. If it was n minus 2, that'd be 2 before. But for arithmetic and geometric, it's only based off of the preceding number, the one right before it. So that's why it's always n minus 1. The n minus 2s would be used for recursive rules that are not arithmetic or geometric. But arithmetic and geometric are much more basic. You're just following these two formulas here. So when we do a quiz on this type of stuff, usually I only put one on the quiz that is not arithmetic or geometric. Everything else is more straightforward, but I like to give you one that's like a little bit of a challenge. And since we're doing multiple choice at this point, you can always test them out, reverse, working backwards from the answers. So you should be fine. So we're going to have a couple challenge problems here because we're going to be writing some recursive rules, and writing the recursive rules can be a little bit of a guess and check type of situation. So that's always a little bit of a challenge. So first thing you want to do when you're given a sequence is, first of all, find out, is it arithmetic or geometric or neither? Because if it's arithmetic or geometric, it's very straightforward. You have a formula to use. There's not too much thinking that's going on. It's more just kind of plugging in. If it's a neither, that's when you have to kind of like challenge yourself a little bit and try to figure it out. So let's take a look first. So if we look at the first one, and it says write a recursive rule. The sequence may be arithmetic, geometric, or neither. So let's look at this pattern here. So it's decreasing, and it looks like it's decreasing by 4 each time. So this tells me that's an arithmetic pattern, and my D value is -4. And of course, we know that the A sub 1 is 21. Now, we're going to use both those pieces of information, whether we write a recursive rule or an explicit rule, but it's going to be used differently. So let's do the recursive rule first. So this is the recursive rule formula here. So if I'm going to do this as a recursive rule, that means that my A sub n is just going to be written like this: A sub n minus 1 plus D, but in this case, my D is a negative, so it's -4. Now, that's the recursive rule. However, whenever you write a recursive rule, it's useless unless you provide something for the user of the rule to start with. So if your rule has an n minus 1 in it, then you need to provide that person or that reader with the A sub 1. So if you have an n minus 1 in there, you need to give them one term to start with. If you had an n minus 2 and an n minus 1, you would have to give them both A sub 1 and A sub 2 to start with, or at least 2 terms to start with. So your final answer for the recursive rule would be not just the actual rule that we wrote here, but also the A sub 1 equals 21 would have to be given, because you have to give them the number to start with, so that then the person could say, all right, I'm going to plug in the 21 and subtract 4, I get 17. Plug in the 17, subtract 4, get 13, and so on. Now, just to review so that you don't get confused between the two, I'm also going to do the explicit that we had done in the previous section. Now, the explicit rule, you wouldn't provide the A sub 1 because it's already built into the rule. So if you remember the explicit rule, you had A sub 1, right? And that was added to n minus 1 times the D, right? So if I have my A sub 1, which is 21 here, and then I have my n minus 1 times my D, which is -4, I would have 21 minus 4n plus 4, and that would give me -4n plus 25, and that's just an A sub n. So this would be my explicit rule. So you can see the difference. They're both a sub n equals, but the explicit rule only has one variable in it, which is that n. And it doesn't have to give you any information to start with because you're just going to start with any number you want for n. So if I want to know the first term, I plug in a 1. The second term, plug in a 2 or whatever. Now, if I'm doing the recursive rule, however, because it's based off of a sub n minus 1, I have to know what is that a sub n minus 1. So you have to give the person something to start with, which is why we put the a sub 1 on the outside, because it's not factored into the actual rule. So that's how you would do the two different ones. So now let's take a look at number 2. I'm only going to do recursive. After I do this one, I'll just do recursive, but just to kind of compare them. Now this one here, this is a multiplying pattern. So 2 times 3 is 6, 6 times 3 is 18, 18 times 3, and so on. So we can see that this is a geometric pattern. It has a common ratio of 3, and the a sub 1 is 2. Now, if I'm going to write my recursive rule here, let me spelling this right here. Recursive rule. All I have to do is give my a sub 1, which we know is 2, and then I'm going to use the formula right up here at the top of my page. A sub n equals the r value, which is 3, times a sub n minus 1. And that's it. That's my recursive rule. Now, if I want to do my explicit rule, the formula was a sub 1 times r to the n minus 1, if you remember from the earlier section. So I would put in my 2 times my 3 raised to the n minus 1. So it would look like this. So you can see that they're going to look differently. So you have to be really careful with that, because when you take your quiz on this stuff, there may be a question where it says, what is the recursive rule for the following sequence? And maybe both of those answers may be a choice. And you need to know that the recursive rule is the one that's got the n minus 1 as a subscript, because it's using a preceding term. It also needs to include the a sub 1 as part of the rule in the given information. The explicit rule is when it's just the a sub 1 times the r with that exponent. So just so you don't confuse the two. Okay. So let's go on now to numbers 3 and 4. All right, so number 3. This rule here, so it looks like it is a multiple, and it looks like it's a multiple of 1/2, right? So my r value here is 1/2. Now this is geometric. So I'm going to write my recursive rule. And I'm just going to follow the formula up at the top of the page, making sure I give my a sub 1 in order to use my recursive rule. A sub 1 is 1/2. That's the first term. And then it's a sub n equals that r value, which is 1/2, times a sub n minus 1. So this would be my recursive rule, and I have to include that a sub 1 to make it complete. You could also write a explicit formula if you want, like we just did on the last one, but this particular lesson is on recursive, so I'm not going to worry about that for now. Okay, so now going on to the next one. Now this pattern here, we're going +3 minus 1, then it looks like, -4, and then -3. It's definitely not an arithmetic pattern. We can see that. So let me see if there's anything geometric going on. Well, 1 times 4 is 4, but 4 times 4 is 16, not 3. So it's definitely not geometric or arithmetic. So this is definitely a neither pattern. So when it's a neither pattern, those are a little bit challenging, because you're going to have to play around with the numbers and see if you can figure out what can you do to the number, any number or term in the sequence. What can you do to that number or numbers to create the next number? So I don't usually like to start with ones, because there's so many things you could do to a 1 and still get a 1. So usually I'll start with maybe like the first couple numbers I see that are not ones or zeros or something like that. So what can I do with a 4 and a 3 to get a -1? So what I'm going to do is, this is my first term. This is my second, this is my third, and this is my fourth, right? So if I want to get my a sub 4, for example, or I want to get that, I'll do it this way. If I want to get the -1, for example, what do I have to do to the 4 and the 3 to get -1? Well, most of you can probably figure out that if you do 3 minus 4, you would get -1, right? So now I'm going to label these with which term they are in the sequence. Well, the -1 was my fourth term. The 3 is my third term. And the 4 is my second term. So I'm just labeling these numbers according to where they are in the pattern. So I'm saying, okay, the fourth number in the sequence is equal to the third number in the sequence minus the second number or term in the sequence, right? So now I just need to change these to n's. So if this a to the 4 subscript is an n, my 3 would be n minus 1, and my a sub 2 would be n minus 2. And you can figure out that mathematically, like you'd say, okay, 4 minus 1 is 3, 4 minus 2 is 2, or I just say, well, the 3 is 1 before the 4 in the pattern, and the a sub 2 is 2 before the 4, and that's how I know I'm subtracting 2 or 1. So this is my recursive rule here, and because I need both an n minus 1 and an n minus 2 in there to start it, I would have to include both of those in my rule. So a sub 1 is 1, a sub 2 is 4, and then you have your recursive rule, which is a sub n equals a sub n minus 1 minus a sub n minus 2. Okay, so let's try a couple more of these neither ones, because they do take some practice. They don't always come naturally to people, which is okay. So don't panic if you're like, what? As long as you do the geometric and the arithmetic, you'll be okay. Like I said, there'll probably be like one that's not going to be arithmetic or geometric when we have our quiz, but you will have multiple choice. That will help you out. You won't be just guessing out of thin air. Okay. You'll have like 4 to choose from, so you can kind of test them out and see which one works. All right, so for number 5, again, this pattern here. Now, there's 3 plus something and then plus. It's definitely not arithmetic because the numbers are jumping up a lot, right? So what if I did multiples? Well, 3 times something equals 8. Well, 3 times 3 is 9, so it'd have to be some weird fraction or decimal, right? But even still, let's just say it was 3. 8 times 3 is 27, not 63. So the jumps here are much bigger than a multiple. So it's not arithmetic or geometric. So it's probably some sort of exponential function. So whenever you figure out the numbers are jumping too much to just be arithmetic or geometric, and they're probably exponential because they're increasing at pretty large amounts, that's when I usually look to see if there's any familiarity with the numbers. So like, for example, if you know your perfect squares, right? Like 2 squared is 4, 3 squared is 9, and so on. So I'm like, okay, 4, 9, 25, 36, like any of those perfect square numbers, sometimes you'll recognize that the numbers are very close, or maybe they're just like one off or something. On this case, I'm noticing I have a 3, then I have 8, and then 63. Now 8 is 1 less than 9, which is a perfect square. And 63 is 1 less than 64, which is a perfect square. And 3 is 1 less than 4, which is a perfect square. So I don't know, maybe there's something going on here with some perfect squares. So if you try to play around with the numbers, like how could you get this 63 from the 2 preceding numbers? Is there anything you could do to that 8 and that 3 to get the 63? Now remember, you can multiply things, you can divide, add, subtract, but you can also use exponents. So you could square things or whatever. And it doesn't even have to use both of these numbers. Like, is there anything you can do to the 8 to get to the 63? Or is there anything you can do to the 3 to get to the 8? So this is where you kind of have to play around a little bit. Now, like I said, because I know that 64 is a perfect square, and it's the perfect square of 8, right? 8 squared, 64. And I know 3 squared is 9, and those are both just one off of the one that's in the pattern. I'm going to play around with that. So to get the 63, if I took the 8 and I squared it, I would have 64, and then I could subtract 1, right, and get that 63. But let's see if that same idea holds true with like the 8. So if I take my 8 and I want to take my preceding number, which is 3, and square it, and then subtract 1. 9 minus 1 is 8. Yes, so that would work there too. And you could even try with that big number on your calculator if you want. So if you did 63 squared and then subtracted 1, would you get 3968? So now once you figure out what the pattern is, so I'm going to work off of my first one here, the 63. But you could work off of the 8. It doesn't matter. I'll just keep it on that actually. So the 8 is the second number in my sequence. So I'm going to write a sub 2. Oops, this was supposed to be 3. And then the 3 is my first number in the sequence. That's a sub 1 and minus 1. So if I make this a sub n, then my a sub 1 is going to be a sub n minus 1, and that's getting squared, and then I'm subtracting 1. So that's my recursive rule. Because I have an n minus 1 in my recursive rule, I need to give my a sub 1, which is 3. So this would be my answer here. A sub 1 is 3, so that's the starting point, and then your a sub 1 equals a sub n minus 1 squared minus 1. So you're taking the preceding term, squaring it, and subtracting 1 to get the next term. All right, so let's try number 6. All right, so number 6, we have this pattern. It goes 1, 2, 5, 26, 6, 77. So again, not geometric, not arithmetic. It's not adding the same thing every time. It's not a simple multiply by 2 every time or anything like that. The numbers are increasing exponentially. So looking at, let's say, the 5, what can you do to the 2? Or what can you do to the 2 and the 1 to get the 5? Or if you want to look at the 26 and figure out what do I have to do to the 5 to get to the 26? Those are some different options. Now, sometimes I like going for the numbers that are double digit because they're still like small enough for you to figure stuff out in your head, but they're not so small that it's kind of hard to think about options. So 26, if I take 26, what can I do to that 5 to get the 26? So I know that I can square it and then add 1. So it's almost the same idea as what we did in the last problem, but it's just adding instead of subtracting. And I could have done the same thing for the 5. Like to get the 5, I could have taken that preceding number, which was 2, and squared it and added 1. So once you figure out what the pattern is with the actual numbers, rewrite it in the terms. So like 5 is the third term, so a sub 3. 2 is the second term, so a sub 2, and that's going to get squared plus 1. Once you have it in terms of terms, or written in terms, then you can replace whatever one you put here. Doesn't matter what one it was, so it doesn't matter if it was an a sub 2, 3, 4, whatever, you're making that an n. And then if this was like a 4, this would have been a 3. So either way you set it up, this number should be 1 less than that. So that will be written as an n minus 1, which will get squared, and then you'll add your 1. Now, once you're done with the recursive part of your rule, if there's an n minus 1 there, you need an a sub 1 also. If there was an n minus 2, you would need an a sub 2 as well. And that's your recursive rule for that one. Okay, number 7. So this one we got, let's say, 1 plus 1, but it's plus 1 would not give us a 2, so it's not arithmetic. Multiplying 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8, but 8 times 2 is not 32. So it almost looked geometric, but then not towards the end, to kind of ruined that idea. So we're dealing with another neither, which would be recursive, where we have to kind of play around with it. So obviously with the 2s and the 4, you know, there's a lot of things. You multiply 2s and add 2, you still get 4, so that's a little bit tricky. Even 2 squared is 4. So I'm going to try to work off of maybe the 8 or even the 32, because that's kind of where it got changed up. So if I look at my 32, how can I get my 32 from the preceding number or the preceding two numbers? So to get 32, I could do 8 times 4. So to get 8, I can do 4 times 2. Let's see if that holds up with the 4. To get 4, I can do 2 times 2. And to get 2, so it looks like to get any number in the pattern, you're just taking the two numbers before it and multiplying them together. So whichever set you want to use here doesn't matter. So if I'm going to go with the 4, right, that was my fourth term, so a sub 4. And I had to multiply the preceding two terms, so the a sub 3 and the a sub 2. And because you're multiplying those, it doesn't matter which one you put first and second. Now I'm going to replace it with the n's. So a sub n equals a sub n minus 1 times a sub n minus 2. And if you reverse the order, that's fine. And then, of course, because you're starting with two things, you need both the a sub 1 and the a sub 2 given to you. So this would be a recursive rule there. All right, and I'm going to do one more with you guys. So let's take a look at number 8 here. So again, you got a couple 1s, then a 4, then a 10. It's definitely not geometric or arithmetic. So we're going to play around this one a little bit. I'm going to look at the 28 and see if I can figure out what to do from there. So, what can I play around with here? So I have a 10 and a 4. Is there any way for me to get a 28 from a 10 and a 4? What could I do there? So let's see. If I add 10 and 4, I get 14. And I know 14 doubled is 28. So maybe I can play around with that. So to get my 28, I can take the 10 plus the 4 and multiply it by 2. Now let's see if that would hold true for like the next number, the 76. So to get the 76, I would want to add the 28 and the 10, which would be 38, and double it. And it does work. And I might even want to try the 10. Does it work for that one too? So if I take 4 plus 1 and double it, it does. So it looks like I've figured it out. So now whichever combination of numbers you use, label it out according to number of term. So since I have 10, that's my fourth term. And then I had to do my third term plus my second term. And then I doubled it, which is just times 2. So that's going to be a sub n equals 2 times a sub n minus 1, because that's the one before it, plus a sub n minus 2, because that's 2 before it. And since I need both an n minus 1 and an n minus 2, I'm going to have to give both of those, and they both happen to be 1. And that would be my answer for that one. All right, so now the next page is just going to be a whole bunch more practice with these, and most of them are not arithmetic or geometric, so I'm not going to spend a lot of time doing them because most of them are pretty challenging, and they will be ones that you take a while. Now, if you want to challenge yourself, go ahead and try them out. I will have the answers provided. If you click on the PDF with the filled in notes answers, all the answers will be there. So if you're curious or you want to just kind of test yourself, they're more than welcome, but I'm just not going to spend a whole portion of the video instructing through them. Okay, I'm just looking to see, there's one that I want to do just because there's a fraction involved. So if we skip down to number 3, I'm going to do that one with you and then we'll move on. Okay, so for number 3, notice there's fractions here, and I'm just going to put the 1 over a 1. So whenever you have fractions and you're trying to figure out that pattern, and this one, it looks like it's like multiplied by 1/2, multiplied by 1/3, multiply. But the easiest way to do it is kind of do it separate for the numerators and the denominators. So like obviously the pattern on the top here, it's just a 1, right? And the bottom is multiplying by an increasing number. So for this one, like if I just look at the bottom numbers, it's times 2, times 3, times 4, and so on. So let's say to get the 24, for example, on the bottom, I would have to do the previous number and I'd have to multiply it by the n value or whatever step it's on. So you'll notice that like this is n1, this is n2, this is n3, this is n4. So sometimes whatever step it's on, like that's the number you're multiplying by. So in this case, that's how I would do that. So if this is my a sub n on the bottom, that would be the answer to the previous one, which is a sub n, and then it would be times n. And of course, because that's all on the bottom of the fraction, that whole thing would go on the bottom. So the a sub n minus 1 times n would go on the bottom, and then you just have the 1 on the top since that stays consistent, and you would have to give that first term. So that would just be an interesting one if there's a fraction. I don't think I'll give you one that hard, and then the rest of the ones on this page are all neithers. So if you feel like you want to challenge yourself a little bit, then you can just go for that. And I'm actually going to stop the notes there, and we will continue the rest of them on the next day. Have a great rest of your day.